Now, students, before I begin today's lesson, I want to ask you one question that we all are familiar and we all know that some object they sink in water and some of the object they float on the surface of water. As we have seen in the last class that when we are doing the experiment of volume, and in the volume we have find the different methods when the object float, how to find the volume, and when the object sink, in that situation, how we can find the volume. So similarly, uh, is there anyone who can explain what are the basic cause that some object float on the surface of water and some of the object they sink? And before you give answer, children, just wait a minute. Uh, I want to make a diagram here. And in this diagram, suppose this is a river. This is a river and the water is, flowing. And if I place a piece of wood or maybe a log, this is a wooden piece, it is a piece of wood, then we know that this object, it float on the surface of the water. On the other side, we have the same river, the water is flowing. And but if I have a stone, a piece of stone, a rock, I mean this stone, then I know that when I put it here on the surface of water on the river, that it's not staying here, it will go down and it will sink, it will reach to the bottom of the river. So the question, this is the question, children, and now please tell me that the answer, why this happens.
Because objects that have a higher density in water, they sink, while objects which have a lower density float.
Buoyancy.
The someone is saying the buoyant force also correct. Okay, Satri is saying that it is about the density. If the object have density higher than the water, they will sink. And anyone else, any other information, children? Iron.
Density is based upon the mass and volume of an object. So let's say like so if the mass divided by the volume is greater than 1, which is the density of water, then it will sink. If it's less, then it will like float somehow.
Okay, Casey, yeah. Good. Aaron?
Nah, sir, I already said it.
Okay. Now, I have the same explanation also that which you have explained, that the concept of density, mass divided by volume, and that you need to compare the density of the object with the density of the medium in which you want to place the object. So let me move to the cognitive, and where you can see the slide. Now, children, here you can see that we have a bar of gold. And in this bar of gold, you can see that the gold bar in figure 1 is about the same size as a size of a brick, but it is much heavier than a brick. And gold is heavy because it is a very dense material. If you go to the periodic table, then you see that it's atomic number, and then you will find it's a very dense material. And there is a lot of matter packed into a small space. Now, children, that as we are going to discuss about the density. So density topic is how it is related with the mathematical equation. Density is given by, actually, if you are going to find the density of any material, so we have mathematical equation, and that equation is mass divided by volume. Different object, they have different kind of density. Different object, they have different kind of density. And different kind of object means, children, wood has different kind of density, air has different kind of density, metal have their different kind of density, even gold has different kind of density, aluminum have different kind of density. Similarly, all other objects, plastic has their own density. So to understand the meaning of density, that you should focus on this equation, that density is mass divided by volume. Initially, that asked you one question that the why the wood float but the stone it sink in the same kind of material in water, and the reason is being that mass divided by volume. In case of a piece of wood, let's just be take this is a piece of wood, and if I just consider a small portion of this wood, small portion of this wood, a small section of the wood, and similarly if I have a stone, this is a stone, you know that it's a spherical object in a solid form, and if I take out some portion of the stone, maybe like this small portion of the stone, and considering that the volume of the piece of wood and the volume of the piece of stone is same, then we find in the same volume distribution of mass is different in case of wood and in case of a stone. Means the material which are more and more and high denser, they have more composition or more distributions of atoms or particles in the same volume as compared to see in case of the wood. Means here why the density of stone is higher compared to the density of wood, the simple answer is that the distribution of mass. In the same space, the distribution of mass is less as compared to the distribution of mass of atoms or particles in case of stone. So more mass is situated in the same volume of stone compared with the same volume of in case of wood. So this is not the case of only a stone or a piece of rock or wood. This is applicable in every material, children. If you find some object sink and some object they float. Now here you can see, children, on my screen, to represent density we use a symbol, and here it is rho. It's a Greek letter. It is rho, R-H-O. And whenever you have to write in your notebook, children, so it's looking like a P, letter P, but it's not exactly P. It's a Greek letter rho, and like it's in italic form. P have turned, it's an italic format, so it's a rho. Or even in exam, you can also write density to write the equation. Density, or even in higher classes, we generally prefer symbols. This density, it is the equation mass divided by volume in SI system, that the mass should be in kilogram and the volume should be in meter cube. Otherwise, in CGS system, in other system, mass can be in gram and volume can be in centimeter cube. So it depends upon when you do questions, numericals, whether the informations are given in gram, mass is given in gram, volume is given in centimeter cube, or in liter, milliliter, whatever the information, depending on the questions format, that you need to find out your answer. So I hope this part is clear, that the density, it's not any difficult topic, children. It's a very simple. You should remember equation density is mass divided by volume. Let's see one example here. In this example, we have a metal block and the mass is given. The mass of the block is given. How much is the mass? 300 grams. And the question is that you need to find out the density of this material, of a metal, this metal block. What metal is this? They have not given, but this is a metal and you need to calculate its density. So suppose you find this question in your exams, in your midterm exams, in your term end exams, or maybe any unit test. So first step, children, write down the equation first. And let me write equation is rho mass divided by volume. I'm also doing for you, children. Even you can also do this question in your notebook. So mass, let me write first mass. Mass is given in the question. It is 300 grams. So I will put here this 300 gram. It is given in gram. So I will write it into gram. Divided by the volume, volume of the cuboid. Volume of the cuboid. So you should be very smart in mathematics also when you are dealing with the physics questions, children, So this is a piece of cuboid, and I know the equation that is given by L cross B cross H for finding the volume. So L is 5, maybe this width is 5, and that the height maybe in any way that this 5, 5, 4. 5 5s are 25, 25 4 is 100. So I will write here that the volume here, the length, breadth, and height, and then you need to do this calculation by yourself on your calculator. Calculators allowed in our exams, IGCSE. So 3, and let me write here, this is in centimeter is the unit. So centimeter, 3 terms are multiplied, centimeter cube. So 3 gram per centimeter cube, or 3 gram centimeter cube inverse. Both are the right answer. Did you get the same answer, children?
Yes, sir.
Yes, sir.
Okay, good. So in exam, students, you will find such type of questions. This question definitely in IGCSE exams, one questions come based on the concept of density. In our board exams, then one question will come in from this concept of density. But remember, children, this is not always about the density. This is not always about the density you need to calculate. From this equation, as density is given by mass, remember I have used now D, so density is mass divided by volume. So maybe any two values will be given, and the third unknown value you need to calculate. Suppose sometimes density is given, volume is given, and the examiner he or she they can ask about to find the mass. So mass will be density multiplied by volume. Similarly, if you need to calculate the volume from the given information, if suppose mass is given, density is given, then volume can be calculated by mass divided by density. So these are the equation, just remember one equation, that density is mass divided by volume. So whatever you need to calculate, you just cross multiply the term and you can find the required value. So let me move to finding density. That this practical work we already have done. We have seen in demonstration of volume. Okay, children, that you please note down even that this table is also given in your textbook, and you can note down this table, that in this table you will find that material is given, a few different kind of materials are given, and their density is given in gram per centimeter cube. In CGS system, that the density is given. Even you can convert into the SI system also. In your textbook, that the density is given in both SI system and in CGS system. So here, from the first material is iron and steel. Their density is both almost same. This is 8 gram per centimeter cube. Copper is 9. Gold, you know that the gold, why the gold density, why it has, because its density is 19 gram per centimeter cube. Composition of particles are, means particles are very closely packed in this small region of space. Aluminum 2.7, cooking oil 0.9, 0.9. That's why cooking oil, the petrol, diesel, they float on the surface of water. The reason is that because their density is lesser than the density of water. Water is given in the last column, that the last row, that water density is 1 gram per centimeter cube. In SI system, this will be 1000 kilogram per meter cube. You please remember, sometimes we need to write this information in SI system in kilogram per meter cube, sometimes in gram per centimeter cube. But remember, children, water density 1 gram per centimeter cube. In kilogram, this is 1000 kilogram per centimeter cube. Air, that's why air floats, and that its density is very, very less than compared with the water, 0.001. And you can compare other values from your textbook also, children. I think in section question, we have 3 questions. Let us do this question, children. Simple questions. Which of these statement is the correct definition of density? Definition of density, children, that the definition of density, you can make a definition from the equation, from the formula, as density is mass divided by volume. So you can use this equation, mathematical equation, in a word form. So 4 options are in option 1 that you can see on the screen, that the option 1 is the density is the mass per unit volume. And the second option, if you see here on the screen, and in the second option, this is Second option is the next is the mass per unit area. Mass per unit area, that's the wrong answer option. Density is the area per unit mass. This is wrong. And the fourth option is here, density is the volume divided by mass. That is also the wrong. And so density is the mass per unit. And this is the right answer here. It's a simple, very simple question, children. We are not going to ask such simple question in your exams. But for your practice, that you should remember that the definition density is mass divided by volume. In second question, children, you try this question, children. We have a block of copper and its volume is given. Volume is given in meter cube. Mass is also given. What is the density of the block? Please find your answer and then compare your answer with the options given here, children. The first option is that density is 9,000, and the second option is 9 kilogram per meter cube. Third one is 0.225 and fourth one is 0.00011. Please find out your answer. Yes, Rishikesh, that I had just seen here, some materials, they float under the surface of water. We are not going to discuss all these things. Actually, that's a huge concept here. And if you want to explore, you can search on Google. Actually, water, we have some object that can float on the surface of the water, some objects under the surface of water, some object partially outside, partially inward, some are completely inward. Okay, so these are the things, children, you can explore by yourself. I will go
Sir,
ahead.
am I on? Can you hear me, sir?
Yes, I can hear you now.
Okay, sir, I think this chapter was given as an assignment, and we actually, I think already, if we have completed whoever completed the assignment has already like did all these questions, sir.
Okay, okay, noted. But just children, did you get the same answer here? This is 9,000 kilogram per meter cube.
Yes, sir.
Yes,
Okay.
sir.
Okay, let
That's
me
the
move to the
same.
next. Okay, so density, and now here one more thing, children. In this slide here, that this is based on density and floating. Just want to give you some information, and I have already given you this assignment as a reading assignment. Now here, the density of water is exactly 1 gram per centimeter cube, and you also familiar that 1 milliliter equal to 1 centimeter cube. And then floating and sink, that the same concept, children. You note down, children, somewhere these two important points. If the average density of an object is greater than 1 gram per centimeter cube, then the object will sink in water. Remember, we are comparing here the density with water. And if the average density of an object is less than 1 gram per centimeter cube, it's less than, so it will float. These are the two necessary conditions here up to a certain extent. But this is not the real situation, children. Sometimes, if I take a needle, this is a needle, it's a needle, it's sharp needle. And when you put this needle in on the surface of water, then, or maybe drop, if you drop, then it will sink, definitely it will sink. But if I beat this needle, with a hammer, means if I make it like a flat, so, and if I put it on the surface of water, then it starts floating. Material is same, still its density is same, but now sometimes that you need to apply other concept also. It's not always that if the density of the material is greater than, more than of the density of water, the object float or sink. It also depend upon the surface area. It also depend upon the buoyant force, upward thrust from the water. So there are so many things, children, that you explore these points by yourself. It's not always about that this mathematical part. If the object, it's a simple concept. It's simple concept that it's a basic concept that object density, if it is more than 1, it will sink. Less than, it will float. Okay, still there are so many things to you can study by yourself. Yeah, that's part. This is an end this topic, children, that the density. And